This video is all about EQ or equalization. Now, equalization involves the technique or procedure of attenuating, which means cutting, or amplifying, which means boosting, particular frequencies on the frequency spectrum. And when we talk about frequency, we're talking about pitch. Now, all sounds are made up of several different pitches which combine together to give a sound its unique sound quality, and this is the reason that a clarinet sounds different from a flute, even though they are fairly similarly shaped. But the subtle difference is in their material and their actual shape, and their makeup and the way that they're played will produce different fundamental tones and different harmonics. Now, this can be seen when you open up a channel EQ strip on a particular track. So what we're going to do is we're going to open up a channel EQ on the vocal. Now we're going to solo the vocal, and we're going to turn off bypass, and we're going to make sure that the analyzer is turned on. And what we'll see is a visual representation of that sound.
Here lies a city on fire, singing along the arsonist's choir. Now here I go.
Now what we'll notice about that is that a large majority of the sound took place between around about 100 Hz and about 2 kHz. So it's 102 kHz or 2000 Hz.
Here lies a city on fire, singing along.
We'll also notice that when the S sounds and the T sounds are prominent, that audio between, or frequency between around 2 and 10K becomes prominent.
Singing along the arsonist's choir, singing along.
Now, our aim with EQ is to try to make parts clear, but also to ensure that perhaps that they are not muddy, and to bring out the parts or the sounds of instruments that we desire. So with a vocal, what we're going to be looking to do is to make sure that it's not too boomy, not too powerful at the low end of the frequency spectrum, which is around here, and to give it a bit of brightness up at the top end. And now to demonstrate the makeup of a vocal, what you can do is you can open up a bandpass filter, which is one that looks like this. And if you increase the decibel up to something in around about 20 decibels, you'll see then that it starts to look like a bell, as they're also known as bell filters, so a bandpass filter. What we're going to do is we're going to loop a particular part of the vocal.
The arsonist's choir, the arsonist's choir.
And we are going to scan the frequencies of the vocal part.
The arsonist's choir, 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 the arsonist.
Now what you may notice is that there are certain bands of the frequency spectrum that produce quite undesirable sounds with EQ applied to a vocal, and there is a reason for this, and these bands can be separated in order for you to have quick control over frequency, which can be applied on a large scale. So the audio bands for EQ are as follows. I don't really want to read everything that's here because you can pause the video and you can read it yourself. But essentially you have sub-bass, bass, low mid, high mid, presence and brilliance that make up the large proportion of the sound that we hear when we listen to music. So with a vocal, what we're probably going to be aiming to do is to remove the sub-bass from this part. And we do that by using a high pass filter. So the high frequencies are allowed to pass.
The arsonist's choir, the arsonist's choir. Now here I go.
So that when this music is played back on speakers with a better low frequency response, you will hear less of the lower end of the vocal part, and that control is really ideal on not just vocals but several parts. The next thing that you're probably going to want to do is you're probably going to want to cut somewhere between 250 and 2000 hertz, and the reason for this is that if you listen at points, you may hear that the vocal sounds a bit horn-like, a bit honky, and it also may sound a little bit too telephone-like. So what we're going to use is another bandpass filter. We're going to cut. Now when you do cut from a sound, it's better to use what's known as a higher bandwidth, or Q, and that's this part here. So the higher the value here, then the narrower the bell, and if we reduce that, you'll see that the bell becomes wider. So we want something narrow if we're going to cut sound. The next thing I'm going to do is I'm actually going to give a bit of presence. So we're going to boost here to ensure that particular parts of speech aren't masked. So here we've got boosting at the upper end can mask important speech recognition sounds. So what we're dealing with here is 4 kHz. So by boosting at 2, we're aiming to give a little bit more prominence to the vocal so that it can cut through and be a little clearer. With presence and brilliance, what we're aiming for here is to give a little bit of a shine and shimmer to the vocals. So what we could do is we can add a high shelving filter at the higher end of the frequency spectrum, so somewhere between 6 and 16 kHz, and boosting with a low value for your Q will help to ensure that it's smooth and it's impactful enough that it's not too obvious. Now this bandpass filter that I've got going on here is aiming to cut some sibilance from the sound. Now sibilance typically occurs at around about 7000 Hz or 7 kHz, and by cutting this I'm aiming to reduce that S sound so that it isn't too prominent when it comes to this part being introduced with the rest of the mix. So there you have a rough approach to EQing a vocal. Every vocal is different because every vocalist sings differently, and remember to refer to the audio bands for EQ to ensure that you're not boosting or cutting in the wrong part of the frequency spectrum. These excerpts are taken from the Mixing Engineer's Handbook by Bobby Owsinski. And a few final closing thoughts, some golden rules of EQ. Now, as for the application of other parts EQ, it's much the same as a vocal. Now, with making parts clearer and giving parts their own space, the best general approach to EQ is to cut before you boost. That said, if we take the kick drum for example, we'll probably want to keep some of that lower end with a high pass filter. So we'll set that to about 60 Hz, and that will control the sub bass part of the frequency. So too would an application of EQ for your bass, just to make sure that the mix is not too boomy. Now already, with these EQ settings applied, we should start to hear a bit of a difference in the overall mix.
Here lies a city on fire, singing along the arsonist's choir. Now here I go. It's started with a spark and burned into the dark. Now here I go.
This concludes the video for EQ. The next video will deal with compression. Thank you for watching.